Okay, guys, let's get going here. This is the day before the test. Tomorrow you will have your partner test. Friday I'm not going to be in class. You'll have your individual test on Friday. You may pick your own partners. Okay? Hey guys, over there. Now, how would you find the series for inverse tangent if you haven't memorized it? I don't want to do the derivative. No, well, if you know what it is, fine. But if you don't know what it is, what is the derivative of the inverse tangent of x? Do you recognize what's special about 1 over 1 plus x squared? I need a series for it. What series is that one? It's 1, this is 1 over, it's the geometric one. Did I do that right? So how would you get inverse tangent then? How would you get rid of the derivative here to get inverse tangent? You would integrate. Integrate that. So once you get this series, should we do that series? This is just to find the inverse tangent. You could memorize it. I don't know that I've ever seen you needing to memorize it. So it's 1 minus x squared plus x to the 4th minus x to the 6th. Am I doing it right? I make mistakes. Is that right? It's the geometric one. I'm just getting inverse tangent. No, it's not like that either. Now you have to integrate it. This had better be odd, right? Inverse tangent's odd. So what's the antiderivative? X minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7. So it's x to the 2n plus 1 over 2n plus 1. That's inverse tangent. Now you could look that up in your book. It's in your book someplace. Did I get it right? I think I did. And then we'll divide by x. Yeah. Either you know it or you would have to work it out, just like I'm doing now. You always have to know the derivatives. Yes. Yeah. True. No, that's the difference. They're listed. They've got to be listed. Oh, there it is. Yeah, it's listed on page 613. Right. So inverse tangent is like the sine, but it doesn't have the factorial. So you can remember it that way. Okay. There's some important things we got to get to, but you guys, now I want the integral of inverse tangent of x over x. So I have to divide by x. So it's x minus x cubed over 3 plus x to the 5th over 5. Now, you may see problems like this. And that's all divided by x. So that will be the antiderivative of 1 minus x squared over 3 plus x to the 4th over 5 minus x to the 6th over 7. Then this is x to the 2n over 2n plus 1. I'm not done yet, Grant, am I? What do I have to do now? Integrate it. So that's equal to x minus x cubed over what now? No, 3 times 3 is 9. Plus x to the fifth over 5 times 5, 25. These are squares, aren't they? This is going to be minus x to the seventh over 49. So this is going to be x to the 2n plus 1, and then it's 2n plus 1 times 2n plus 1 plus c. That was the integral of inverse tangent divided by x. Now, they might give you the integral of the sine of x divided by x, because you should memorize the sine. If you've memorized the inverse tangent, then you would actually start right here. I didn't have it memorized, so I didn't know what it was, so I worked it out. Now, could I have done it using derivatives and the Taylor polynomial? Yes. But honest to God, I don't want to be taking the derivative of 1 over 1 plus x squared, because that's just going to get harder and harder because of the chain rule. So it's nice if I can see the relatives to the 1 over 1 minus x. I don't always. There is your Taylor polynomial. Did I type it correctly? No. Need my factorials there. Okay? Maclaurin series is when a is equal to 0. Usually they give you the Maclaurin series. Now, looking at that function, without taking a derivative, there's something interesting here. I'm going to write this Taylor polynomial underneath. Okay, Grant, you're going to miss this, because they might ask you for the 20th derivative, and you're not going to take the derivative 20 times. So remember how we generate this? These are the numbers that are in front of, actually, let's do the Maclaurin series. M of x is equal to f of 0 plus f prime of 0, x, plus f double prime of 0, x squared over 2 factorial, plus f triple prime of 0, x cubed over 3 factorial, etc. These numbers in front here, these are just the constants. So if I look at the x squared term, this 2/3 is equal to that coefficient. Now, do you guys have that over there? Because that's tricky. These are just plain old numbers. So this part right here, f double prime of 0 divided by 2 factorial, let's just copy the term, x squared equals 2/3 of x squared. What could I do with the x squareds? Cancel them out, so that the second derivative over 2 factorial has to equal 2/3. What's the value of the second derivative then? Is equal to 4/3. Can you just take the derivative of the function to get that? Yeah, you can. But what if it's the 20th derivative? What if it's the 100th derivative? You got trouble. Because I'm going to multiply this by 2. This is the Maclaurin polynomial. The 2/3 is the coefficient of x squared, which is this. So, what is f of 0? What's added here in the front? What's the constant? No, it's 0. I don't see a 1. What's the coefficient of x? Negative 1/2. So f prime of x is equal to negative 1/2 of 0. Sorry. Okay? What if I take the derivative of this, just the way we've always done it? F prime of x is equal to negative 1/2 plus 2/3 times 2x plus, oh no, sorry, minus 3/4 times 3x squared. That's the first derivative. Now, what's the first derivative at 0? Equals negative 1/2. And what happens to all of these guys? They're 0. I can do it two ways. But if I ask for the third derivative, and I don't want to keep taking derivatives, I have that. This, what does the Taylor series say that is? Negative, I'm going to 3/4 x cubed is equal to f triple prime of 0 over 3 factorial x cubed. That's the degree 3. It's not the third terminal. That's this one. Do I have it up here? That's this one. Remember, these are just the numbers that are in front of the cubic. So what is the third derivative? What happens to x cubed? They cancel. So I think it's easier for you to see that. So negative 3/4 x cubed, oh, sorry, x cubed is gone, equals f triple prime of 0. These are not the derivatives in front of x cubed, but it's the derivative divided by the factorial with it. And so if I solve for that, f double prime of 0, triple prime of 0, thank you. Just going to catch that, is negative 3/4 times 3 factorial. And you could simplify that if you want, but who cares? Mm-hmm. These are the coefficients of the Taylor polynomial. Remember, the Taylor polynomial was C0 plus C1 times x plus C2 times x squared. These are the coefficients there. And remember how you found the coefficients on your Taylor project? Those are the derivative divided by the factorials. Making that connection is not easy. I did the Maclaurin series. I equated the terms. So what's the nth derivative going to look like? It's going to look like this. Let's do the nth derivative. It's, I don't like this color. It's negative 1 to the n, and it was n over n plus 1, right? And then that was x to the n. That's going to equal the nth derivative at 0, x to the n over n factorial. What happens to x to the n's? They cancel. I'm just equating these coefficients. Can I find the nth derivative? Sure. I get negative 1 to the n over n plus 1 equals over n factorial. What will I do to both sides now? Multiply by n factorial. So it's weird. It looks like that. So it's negative 1 to the n. It's n factorial n over n plus 1. That will give me any derivative I want. You'll see some of that on the exam. I haven't seen it for a while, so I would say it's probably a pretty good chance. You'll see it on this year's. Partner. They're both, I believe we decided both were partner. But your final is not partner. Yeah, it's on the AP scale. Yeah, yeah. I know. A lot of people are going to be gone on Friday. I know. They're all partner. And the one tomorrow, I think we decided to make it partner. I'll let you know. But tomorrow for sure is partner. There's some multiple choice, and there's some free response. You do the free response, all the free response, you're fine. You will have done it. It happens. Tomorrow for sure is partner. Okay, let's do another problem. And then we'll give you time to work, because the next problem on here is 2006. We already did it. Okay, you guys ready? Hello? Okay. Do you know what the cosine of x is, the Taylor polynomial? Is minus. They alternate in sign. That's the way to remember it. E to the x does not alternate in sign. You guys you'll find your own ways to memorize it. At least that's what I do. And this has to be even, so they have to be even numbers. It's just negative 1 to the n, x to the 2n over 2n factorial. Okay, now you guys, you could take the derivative or you could just look at the Taylor polynomial. Now this is the one, the Maclaurin series, excuse me. This is centered at 0. What's f prime of 0? This is f of 0. Here's the Maclaurin series. Plus, then it's f prime of 0 times x over 1 factorial plus f double prime of 0, x squared over 2 factorial plus f triple prime of 0, x cubed over 3 factorial. So f of 0 is 1, which you knew the cosine of 0 was 1, right? What's f prime of 0? Careful. Careful. This is x squared. That's x squared. Well, then what does f prime of 0 have to be? 0. You could take the derivative of this and you see that it's 0. Okay, so f prime of 0 is 0, which means that I have a candidate for what? If the first derivative is 0, maximum or minimum, right? So what is f prime of 0? It's 0. Therefore, possibly, no guarantees. A max or a minimum. How am I going to know? I can't do a first derivative test. I have to do a second derivative test. So what's f double prime of 0? Here is f double prime of 0 divided by 2 factorial. So what's f double prime of 0? F double prime of 0 divided by 2 factorial equals negative 1/2. So what's f double prime of 0? Negative. If you want to be really safe, just say it's negative. But because if you say it's negative 1/2, they're going to mark it wrong. Because it isn't. It's negative 1. But what do I need out of that? I need the fact that that's less than 0. Therefore, my function, I forget that I know what a cosine curve looks like, is upside down, concave down. Therefore, it's a max. But you knew that, right? This is the cosine curve at 0. Now, remember how we center these things? I was just thinking of a way to help you understand that better. Remember on the project grant, I'm almost done. If I did a linear approximation, it wasn't very good except when I was really, really close to 0. What if I want the cosine of pi over 6 plus 0.1? Okay, guys? Zach? I don't want the linear approximation. It's not good enough. What about the quadratic one? It's better. But if I want to do this one, I would actually do my Taylor polynomial centered at pi over 6, because then I don't need very many terms to get the approximation to this. But the further I get away from wherever I found my derivatives, the worse this is and the more terms I have to have. So that's why we center it at a certain place. It's just writing the equation of a line, not at the origin, someplace else. That's all. So I could find the equation of the tangent line here, and that's really good at pi over 6. If I add a little bit there, it's going to be almost exact. It's going to be that good. Whereas if I take the Taylor polynomial, the Maclaurin series, the one centered at 0, it's going to be off unless I include quite a few terms. We don't want to include many terms. If you go into biomedical engineering, they only use 2 or 3 terms. That's it. This is not an easy thing to figure out. have to, the coefficient of x squared has to go, these have to match. There was no x, so the only way for the x's to go away was f prime had to be 0. If I didn't have that, then the second derivative would be 0, in which case I would know nothing. The first derivative is 0, the second derivative is 0, I still know nothing. Okay? Because second derivative being 0 does not have any concavity. Okay, the next thing was 2006. But work on the purple packet. I would do 2011, number 6. Notice they're always number 6. And I think the Taylor palette, we did those. Am I missing one yet? We did it. We did it yesterday. If you want the answers, there they are. Notice that you get 5 points for doing the ratio test. Now, they did their endpoints a little differently than I would do them. If I look at the endpoints, like on this one, the series looks like this. It's n over n plus 1. It's alternating, so it's an alternating series test. And on any series, we only look at the positive terms of that sequence. And the limit of that sequence of b sub n must be 0 for this to converge. But what is the limit of n over n plus 1? It's equal to 1, which is clearly not 0, therefore it diverges. Okay? I don't have a name for it. It's just the limit of the sequence must be 0. They actually said that that was increasing because the limit of individual terms is not 0. I said the same thing. It's got to go to 0. I would have said the sequence. And then you got points. That's easy. No? Ratio, you can make mistakes. Follow through on your mistake. If you make a mistake, just keep following through. We will follow through with you unless you make it an easier problem. And we talked about last year's problem. What's that? I did, because I graded that one last year. And they were very generous on that problem last year. So if you want to practice on 2012, the average is, I think, 5 points out of 9. You're not going to get 9 points. That's okay. You can get 5. Some of them, the average was 1. So I'm going to let you guys have that purple packet. All the answers are online. I can make a smart board and bring it up. Wait, let me stop this.